Hello students, now we will discuss heat and thermodynamics. Heat and thermodynamics. The next topic is thermodynamics. Thermodynamics is that branch of physics which deals with the relation between heat and motion. Thermodynamical system. It is a collection of extremely large number of molecules arranged in some manner such that collection has some value of pressure capital P, volume capital V, and temperature capital T. System may be solid, liquid, or in gaseous state, or their combination. Thermodynamical variables. The quantities like pressure P, volume V, and temperature T of the thermodynamical system, which can describe completely the thermodynamical behavior of the system, are known as thermodynamical variables. Equation of state. The relation between pressure, volume, and temperature of the system is known as equation of state. For example, for n mole of ideal gas, the equation of state is PV is equal to N into capital R into capital T, where capital R is gas constant. Now, thermodynamical process. Whenever thermodynamical parameters of the system are changing with time, a thermodynamical process is said to be taking place. Different types of thermodynamical processes. Number 1, isothermal process. A thermodynamical process in which temperature of the system remains constant is called isothermal process. In isothermal process, the product of pressure P and volume V of the system is always constant. That is, PV is equal to constant, as the internal energy of the system depends upon the temperature of the system, and in case of isothermal process, temperature of the system remains constant. Therefore, the change in internal energy of the system in isothermal process is zero. In isothermal process, work done by a system is equal to heat given to the system. So this is something about the isothermal process. Number 2, adiabatic process, a thermodynamical process in which there is no exchange of heat takes place between the system and its surrounding, is called adiabatic process. For adiabatic process, equation of state is P into V to the power gamma is equal to constant. Here gamma is equal to Cp upon Cv. Cp is specific heat of gas at constant pressure, and Cv is specific heat of gas at constant volume. As Cp is always greater than Cv, hence gamma is always more than 1. In adiabatic process, if work is done by a system, then its internal energy decreases, and if work is done on the system, then its internal energy increases. That is, if gas expands, its temperature decreases and vice versa. This is the adiabatic process. Number 3, isobaric process, a thermodynamical process in which the pressure of the system remains constant is called isobaric process. For this process, work done W is equal to product of pressure P and total change in the volume delta V of the gas. That is W is equal to P into delta V. Next is isochoric process, a thermodynamical process in which the volume of the gas remains constant is called isochoric process. In isochoric process, work done is always zero. Therefore, the heat energy given to the system is always equal to increase in its internal energy, that is Q is equal to delta E. Number 5, cyclic process, a thermodynamical process in which the system returns to its original state is called a cyclic process. So these are some thermodynamical processes. Now indicator diagram or PV diagram. The graph plotted between two of the three thermodynamical parameters is called indicator diagram. For example, the graph plotted between pressure and volume is called indicator diagram or PV diagram. Suppose this is the point O origin, this is x-axis and this is y-axis. Along the x-axis we plot capital V volume and along the y-axis we plot capital P pressure. That is along x-axis we plot volume V and along y-axis we plot pressure P. So this is the graph for two different types of thermodynamical process. This first one is isothermal process and next is adiabatic process. As adiabatic process is more steeper than the isothermal process. Now next is, again suppose this point is O origin, this is x-axis and this is y-axis. Along x-axis we plot volume V, along y-axis we plot pressure P. This is the graph, PV graph for the given process, and this type of process is called isobaric process as pressure remains constant for this process. Now next one is, suppose this is O origin, this is x-axis, this is y-axis. Along x-axis we plot volume V and along y-axis we plot pressure P, and this is the graph, and this is the graph for isochoric process as volume in this process remain same or constant. So these are some PV diagram for different types of isothermal, adiabatic, isobaric, isochoric, that is for thermodynamical processes. So thank you very much.